Hey guys, today we are taking a look at proportionality theorems within triangles. So first off, we have a new theorem, triangle proportionality theorem. It says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So let's look at an example to see what this means. So in the diagram, QS is parallel to UT. We see that in the picture. RQ has a length of 10, RS has a length of 12, and ST has a length of 6. We want to know the length of segment QU. So if it's dividing proportionally, basically what this is saying is that we can divide out the pieces of the big triangle when we see those parallel lines there. So 10 and X match up from the left-hand side of the triangle, and 12 and 6 match up from the right-hand side of the triangle. From there, we can cross multiply and find our answer to X, which is the length of QU. So I get 12x equals 10 times 6 is 60. And I'm going to divide by 12 on both sides. So I get x equals 5. And so the length of QU then would be 5. So it divides it proportionally. It cuts it apart at the same proportion, at the same rate or ratio. Okay, so then it wants us to find the length of KL. Well, all it's done here is turn our triangles sideways. We're going to use the same process if we call KLX again. And it doesn't matter which one we put on top. So if we put JK is 18 over our unknown side of X equals the bottom part of our triangle on the other side is 24 over 44. Okay, and then we're just going to cross multiply. So 24x equals, we have 18 times 44, and 18 times 44 is 792. So we divide by 24 on both sides. We get x equals 792 divided by 24 is 33. So in this case, we get that KL is going to be a length of 33. Okay, converse of the triangle proportionality theorem says if the line divides two sides of a triangle proportionally, then it is parallel to the third side. So if RT over TQ is equal to RU over US, then we know that that segment TU is parallel to segment QS. So determine whether QT is parallel to RS. And so I'm going to show you a couple different methods, and you can decide which one you like better. So method 1. Both methods are going to start off the same way. You're going to set them up so that our fractions, our ratios, are matched up. So I have 36 over 80, and I have 18 over 38. Notice I'm not putting an equal sign there because we don't know if they're equal. That's what we're trying to determine. So one thing you can do is just reduce those. You put 36 over 80 in your calculator and you reduce that down, or if you know they both divide by 4, then we get 9 over 20 on this side. If we reduce 18 over 38, we get 9 over 19. They both divide by 2. obviously 9 over 20 and 9 over 19 are not the same thing. So they are not parallel. Method 2 is going to use our cross-multiplying method. So again, we're going to start with 36 over 80. We're going to have 18 over 38. So now you're just going to cross-multiply, and you want those two numbers to be the same thing. So 36 times 38 is 1,368. And 80 times 18 is 1,440. Those two numbers are not the same, they're not equal, so we can say that QT is not parallel to RS. Okay, so kind of real world example here. Spoiler for a remote controlled car is shown where the length of AB is 31 millimeters, the length of BC is 19 millimeters, the length of CD is 27 millimeters, and the length of DE is 23 millimeters. Explain why BD is not parallel to AE. So I'm going to write this in because that's a lot of information. So AB is 31, BC is 19, CD is 27, and DE is 23. So if we set this up just like we did before, 27 over 23 and 19 over 31. Well, first off, neither of those reduce. So I can see right away that they're not going to be equal to each other. So we can put equal sign with the cross through it. So if they're not equal, the ratios are not equal, then BD is not dividing the two sides of the triangle proportionally. So BD does not divide the two sides proportionally. Which makes it so that the segments are not parallel to each other. Okay, so the next theorem says if three parallel lines intersect two transversals, then they divide the two transversals proportionally. So if you look at our picture, it says UW over WY is equal to VX over XZ. So same process that we're using for the triangles, but this time we're looking at three parallel lines with two transversals. It's not a closed off triangle at the top. So if you look at this next picture, it says a farmer's land is divided by a newly constructed interstate. The distances shown are in meters. Find the distance CA between the north border and the south border of the farmer's land. We can use the same process to set up and find BC, and notice that's not what the problem's asking for. We can go back and find that later. So we can find that length BC, though, by setting up our problem the same way. So we have 2,000 over our unknown length equals 2,500 over our other unknown length. So then we can cross multiply. So I get 2,500x equals 2,000 times 3,000 is 6, and then it's going to have 6 zeros behind it since each of those has 3 zeros. So 6 million. We divide that by 2,500. So I get that x equals 2,400 when I divide that out. But that's not our answer. We need to go back and look the distance from C to A. So the distance from B to C is 2,400, and then A to B is 2,000. So CA, using our segment addition postulate, would give us 2,000 plus 2,400, or 4,400, and our label would be meters. Okay, so one more theorem today. It says if a ray bisects an angle of a triangle, then it divides the two opposite sides into segments whose lengths are proportional to the lengths of the other two sides. That sounds a little confusing, so let's talk about what this means. If you look at the picture, it says AD over DB is going to have the same scale factor as CA over CB. So the two ends there will be proportional to the two sides where it's dividing it. So looking at this picture, the two end pieces will be proportional to the two side pieces. So I have 8 over 12 as the two sides there, and I know those values. Now on the other one, 8 matches up with X, but then I don't have a length for the other side. So you want to think back to our segment addition postulate. If we know this whole thing is 14, then this piece is going to be 14 minus whatever DG is. And right now, DG is just X. So we're going to do 14 minus X there. So now we're going to set up to cross multiply. So I get 8 times 14 minus X is equal to 12X. So now we need to distribute. So 8 times 14 is 112. And then 8 times the minus X is minus 8X equals 12X. So I'm going to add 8X to both sides. And I get 112 equals 20X. And I'm going to divide both sides by 20. So I get that X is 5.6. But we don't need what X is, we need DG, which does happen to be X. So DG equals 5.6. We didn't have to do any more solving there to get to that answer. All right, so we'll keep working at this in class. If you have questions, please come in and see me. I will see you in class. Have a great day.